web application. There are lots of options. So if we go back to Visual Studio, I already have all my projects built. But if I want to come here to Solution and add a new project, it's going to ask me to pick what kind. So it lists some kinds of projects I could create here. I could create, those are Visual C#. I could go into Visual Basic. There's a library, there's a bunch of them. There's some test projects, and so on. And others I could download from online. So I'm just going to cancel out of that. But the first step is just knowing what kind of project you want to create. All right. Okay, now, also we had that question about building. This slide is talking about the difference between compile time and runtime. So when a project is compiled, so when your project is compiled, the source files are translated into what are called object files. And that the object file is just a translation of the program, but it's in what's called Common Intermediate Language, CIL. And then each object file is combined to create the assembly for the project. And typically, you're using lots of stuff from the library, from the C#.NET library. Generally, the code from those libraries isn't included in the assembly. Instead, there's symbolic references that says, okay, what needs to be, it says I'm referring to this method that's not actually here. It's in the library. Then when you run an assembly, so when you run a program, as it runs, it's translated on the fly into the native machine code. So it's actually compiled again as it starts running. That's called just-in-time compilation. When you need to execute this missing method, for which there's only a symbolic reference, then that library is loaded into memory if it's not already there, and execution continues. The libraries are what are called DLLs, dynamically linked libraries. And I just want to show you the difference. So this is one model. This is what happens if you have a statically linked library. Suppose you write a project that produces assembly 1, and assembly 1 uses code from static library A and static library B. What happens is, if you're doing static linking, is all that stuff is compiled into a single, is linked into a single package, so it's completely self-contained. Okay? Then you do assembly 2, and let's say it uses libraries A and C. They're combined. And the same thing for 3 and 4. So the advantage is each of these things is completely independent. It's self-contained. What's the disadvantage of static linking? Yeah?
If you're using really big stuff that have to all together, so that the self-contained package is much larger.
Okay. So what he said, I'll paraphrase. Notice, think about the memory footprint. Suppose you're running all 4 of these programs at the same time. Each has a copy of the static library A. And this is read-only memory. It's not like this, the program changes at runtime. It's always the same. So you're wasting memory. These could be big, and you're wasting memory in the computer. Okay? Same thing, we're using 2 copies of B and 3 of C. So dynamic linking looks like this. When you create the assembly, it just remembers, at some point I may need library A, and at some point I may need library B. And when it comes time to use library A, then the runtime system either loads the library into memory and tells the assembly where it is so it can find the code. Or it notices it's already in memory, and you end up with all these 3, 1, 2, and 4 all sharing the same copy of the library at the same time, which is fine. Because like I said, it's read-only. So that's what, you hear about DLLs all the time. That's what it's talking about. It's just libraries that are loaded as needed and are shared between processes. What can you see as a disadvantage of that compared to statically linked libraries? From an engineering point of view. Yeah?
It's less portable.
So it's less portable. Well, it means that it's true that when you need to run it someplace where the libraries are installed, you've got to have the .NET libraries available in addition to having your project available. Yeah?
If you run a library and changes something in it, they affect the other assemblies?
Yeah, well, yeah, but the libraries don't change. Right? It's just code. Yeah?
What if you only use it once?
Okay,
You don't
so
really
what if,
have
could you
cache.
expound? What if you only use it once?
Well, if you only use it once, then you're not going to continue to need access to it as the program continues. So it'd be almost more worthwhile to your memory to use it and then let the garbage disposal system take care of it.
Okay, but for statically linked, it's hard to imagine the library being unloaded.
Yeah.
For dynamically linked, it is possible to imagine. So that's sort of an advantage for dynamically linked. What would be a disadvantage? Yeah,
As you need it, you need to wait for it to load.
Exactly.
To slow down your execution.
exactly. It slows you down a little bit. Because over here, if you're calling a math method in this library, boom, you just make the call. It's already loaded in memory for you. Once the assembly is up, there's no more loading done. Here, you try to execute a math library function and there's a pause while the runtime system finds the library, loads it if necessary, and goes. And so it makes sure you can slow down your program. Furthermore, you can directly make the call. This assembly can know exactly the address of memory of this method and get to it right away. Over here, there's a level and direction. You want to call the method, you have to come over here and then find out where to go from there and then the next method. So there's a slight performance hit. All right, now I'm going to stop using slides. I'll go back and forth between slides and code. I just put this here, not so I'll stand up and talk about it, but just so you can come back later and see what I talked about. So these are some of the things I'll be talking about as I show you C# code. And then I have a little more detail on particular things we're going to talk about. So let's we'll come back to that later. So let me see if there are any questions I can answer at this point that you may have not asked yet. Okay. All right, so I've got these 4 projects. Let me just show you a few things. Often you want to do something to a project. And the way you usually do that is you just right-click. So I right-clicked on delegate examples there. And there are these things you can do with the project. So like if I tell you to clean your project, I right-clicked, I click Keep Clean. That just basically eliminates all the object files and then eventually be rebuilt. Right now I don't need to do that. So we're going to look at this, the project is called Hailstone. Let's look at I'm going to look at its properties and see what kind of project it is. So over here it is saying, I'll click on the application, it is a class library. See output type right here, class library. So this is not a program you can run, it's a program designed to be used from elsewhere. So I'll close down the properties. And basically that means there's no main method in this class. The result of building this Hailstone project is a DLL that can be used from elsewhere. Okay, so I've got the comments written here, so I'll go over them and talk to you about them. If you program in Java, you know that you import packages. In C#, you are using namespaces. So instead of saying import java.lang.whatever, you say using system, using system.collections.generic. So what that says is, this gives the ability for this class to access anything in that namespace right there. So the namespaces are hierarchical, just like Java packages are hierarchical. And you declare, just like you declare the package a class belongs to, you declare the namespace something belongs to, that way. Anything inside the braces will belong to that Hailstone namespace. The one difference, it's an important one, in Java, if you have a package java.lang, if you have a class java.lang.math, there'll be a folder somewhere called Java that contains a folder called lang that contains a class called math. There's physical containment. Here it's just logical containment. There's no, these things don't nest physically in the file system. So it's just a logical hierarchy of classes. So anyway, everything we're about to define down here belongs to namespace Hailstone. Now, once you get inside the namespace, it starts to look a whole lot like Java. Okay? So at the high level, it's different. Inside, you you'd be very comfortable if you've never seen C# in your life. So first thing I'm doing is I'm defining a class called hail. This comment right here, this is, if you've done Java, you've done Javadoc. This is the equivalent of Javadoc, these triple slashes. So when you write a method, you want to make the doc comment, documentation comment, do // return, and it will give you a template to fill out. One thing to be aware of is, you know that when you put a doc comment on something like a Hailstone Lister, that means that when you hover the mouse over anywhere where Hailstone Lister appears, the documentation occurs. Okay? And that's why we make doc comments. But this thing here, this class, this assembly is meant to be used in a different place. And the Java doc won't work right unless you go to the project properties, go to build, and come down here to where it says XML documentation file and make sure it's ticked. So right there it's turned off, there it's turned on. You want to turn on the building of an XML documentation file so that in addition to your assembly exporting code, it also exports the documentation. If you don't have that ticked on, you won't be able to see the documentation from another project. Okay? So any time you're doing a shared library, be sure that's ticked on. It may be on by default, I'm not sure. Used to not be, but it may be now. Okay, so back to hail.cs. That's different. What do I suppose that means? You can read the comment and see what it means, but what does it mean to declare a top-level class static? That's something you can't do in Java. Yep?
It means you don't need the parent class to call its function.
No, nothing to do with parent classes. Yeah?
Oh, you don't need an instance of the class?
It's not just that you don't need an instance of the class, it's you can't have an instance of the class. Yeah?
So you would just reference it from the namespace directly?
Well, no, it's the only things the class can contain are static things. Okay? In Java, sometimes you create a class, like the math class in Java contains only static methods. You can create a new math object by saying new math, but it's kind of useless because there are no methods you can invoke on. So oftentimes we write classes just to hold static methods. Sometimes we write classes because we're creating a new type of data. C# lets you distinguish. So I call this class static. If I try to put a constructor in here, it won't let me, because you cannot say new hail. What you can say is hail dot hailstone lister. And you can call the static methods in the class. So that's just sort of a neat thing that C# has that Java doesn't. Okay? Now we have this method right here. It's a static method. It's called hailstone lister. It takes a parameter start and it returns an IEnumerable of ints. So you can see that just like Java, C# has generics. We can say IEnumerable of int. But unlike Java, you can use what you think of as primitive types as the parameters. You don't have to have these foolish wrapper classes like Java uses. Now, an IEnumerable it's an interface. By convention, things that start with a capital letter I are interfaces. So that's an interface, what it does, what that class provides are the methods needed to iterate over something. So you have a for each loop in Java. You also have a for each loop in C#. So an IEnumerable object, an IEnumerable int could be a list of ints, or an array of ints, or an array list of ints, or a set of ints, or whatever. It's just sort of to make it possible to write loops that consume them. So that's what we're returning there. So down here, notice that inside, I am creating an empty list. I'm storing a variable called numbers, and then in the end, I return it. So I'm actually returning a list of integers, but a list of integers is a kind of IEnumerable of integers. Okay? So I could change it. Instead of using list, I could use linked list or something, and it'd still be fine. So it just gives me freedom as implementer to choose what physical thing to create. Now this used to trouble me a lot. Declaring, not giving the type, just saying, okay, numbers is a var. It's a variable. And I've gotten used to it. People look at this and think that you can store anything you want in numbers, but you can't. you can't come back and say numbers equals 2. Because it says can't convert an int to a generic list of ints. Okay? So you can use var as a shorthand if the compiler can figure out what type you're storing it. So it can tell from right here, yeah, you're creating a list and storing it in this variable, so it infers that the type is list. But it definitely has a type. You're just not declaring it. The compiler's figuring it out for you. I would use this sparingly. It's easier to read the program if you can see the type of the variable, in my opinion. But sometimes it gets to be a pain to type out big, long type names. So it's just sort of, it's a little shorthand. Now, the details of the method aren't that important. It's generating the hailstone sequence that begins at that integer. And the hailstone sequence, for those of you who don't know, you start somewhere like 5, and the rule is, if it's odd, you triple it and add 1 to get the next element in the sequence. If it's even, you divide by 2, and you stop when you get to 1. So if you start at 15, the next would be what? What would be next in the sequence? It's odd, so what do? Triplet and add 1, that gives you 16. That's even, so you divide it by 2, you get 8. Divided by 2, you get 4. Divided by 2, you get 2. Divided by 2, you get 1. And that's the end of that sequence. And it's an open question whether it's not known. No number's ever been found that doesn't eventually lead back to 1. No positive number. But it's not known that that's necessarily the case. It's sort of an open problem in mathematics. So what this does is you give it the start point, and it gives you back a list that contains the hailstone sequence, beginning at start, ending at 1. And you can see how it works. It just says while start's greater than 1, it adds start to the list, it figures out the next one, and then iterates. Adds start to the list, figures out the next one, iterates, and then when you're all done, you just add 1 to it. That returns that list. Okay? So, straightforward if you've seen Java before, and really straightforward if you've seen C# before. But before I look at something else, are there any questions I could answer about what I've shown you so far? Yeah?
I just wanted to add, with static, isn't it that it's also defined at runtime?
It's also what?
Like it's defined at runtime, isn't that?
No, static doesn't mean that.
Okay, I thought that was.
Static means, a static method is one that you can call, you just use it. It's not, you're not invoking it on an object. You just call it. It doesn't have an implicit parameter. Okay, so we have this project now, and when it's built, it's going to contain this class that can be used from elsewhere. So let's go up to demo up here and see how it's used. So here's demo.cs, and you can see I'm using Hailstone. That's not enough to use Hailstone because the Visual Studio has to know where is the assembly that defines that namespace, and you have to tell it. So actually, I see that I've made a modification here I want to save before I forget. So you have to, what you have to do is, if you want to use a different assembly, you come here, you go to references, and you add a reference. Okay, so I would want to add a reference to Hailstone. I've already done that. So you'd use this thing to navigate to another project and say use it, and then say OK. And then you see Hailstone shows up in this list right here. So if I take Hailstone, I can remove it, the reference. And now you notice I've got these error messages popping up because it doesn't know what Hailstone is. So to fix that, I need to go back to demo. Well, easier to click on references. Click on reference, add reference, go find Hailstone, tick it, and say OK. Okay, and now you've got that. So if you want to use a different assembly, you have to reference it. Yeah?
So if you were developing like a program in C# outside of an IDE, I don't even know if anybody ever does that, but if you were, how would you be able to access that kind of thing? Is there like a file you have to modify?
No, it depends what. If you're not in an IDE, you're compiling things from the command line. And there are command line parameters you provide that say where to go look for assemblies. Okay, so this is another static class. And here's the main method. So notice what I've written here. For each integer in hail.hailstone is 7. So this is what a for each looks like in C#. In C, in Java, it's more like for int m colon hail.hailstone. So this just runs and writes out every number in this list. It iterates through the list and writes them all out. That is shorthand for this. So this is an IEnumerable object. It has an IEnumerable object. It has a method called getEnumerator. So you get that object, which I call hail, and that object provides a move next method and a current. So what I'm saying is, essentially, this is gets converted at some level to that. That's how it works behind the scenes. Yeah.
So would it just give an error if you, say, put a right line right before the first move next call?
Okay, an error if I did what?
If you took the console right line with if you tried to reference the current in the enumerator before calling move next the first time.
You get an error, right? You got to move to it before you can use it. Yeah. All right. So you see that I've written code here that it calls hailstone and iterates. It gets back an IEnumerable. It iterates through it, prints everything out in it. And there's some other examples here of other things you can do with IEnumerables, like this one writes out the first element of the sequence. Okay? There's a method on IEnumerables that will find the maximum one in the sequence and print it out. This will print it out in reverse order. So there are various methods you can apply to the IEnumerables. Okay, now let's think about this. These sequences can get pretty long, right? I can run it here. We can see. This is a good time to point this out. When I run, it's going to run. It has to know which project to run, and it's going to run the one that's highlighted. So you can see grep right here is in boldface. So if I were to run the program if I were to run right now, I would run that project. So I need to make this the startup project. So I right-click and I say set as startup project. Okay, now demo is in bold. And so when I run it, up pops the window and we get the output. And you can see 7, we went from 7 down to 1, there's like 15 numbers or something. But imagine starting with, a number in the billions. It could be a very, very long sequence. And our method that builds that sequence builds a list that contains the whole thing before it returns it. And that's fine if you're ultimately going to consume the whole thing. But what's the drawback of producing the entire sequence in a single list before you can do anything with that list? Yeah?
If the sequence is too long, you might run out of memory.
Right. You could run out of memory. Right? What's another disadvantage? Yeah?
We might not need to construct a whole list for what we want. We might go like halfway through or something.
Right. We just want to see what the third element is. But why create the whole thing? So C# provides something, they're called iterators, that solve these problems. And I'm just going to briefly show you what I mean, and then we'll take a break. I'm going to go back into Hailstone here. So this was the version we looked at. Now, how does this version here differ? Look at this method right here called Hailstone Printer. How does it differ from the version we just looked at? You say it's a void method. It's not returning anything. What's it doing instead? Yeah, it's just printing out the ones as it discovers it. Does this have to build a giant list before it can start printing numbers? No. It generates one, prints it. Generates the next one, prints it. But the method we looked at in the other project, it was also just printing out the Hailstone numbers, but it had to generate all of them before it could print the first one. That doesn't seem fair. And so to solve that problem, we use iterators. And this is what an iterator looks like. And I'll explain it later, but the basic idea is you call Hailstone, it figures out what the first Hailstone number is and gives it back to whoever called it. And whoever called it can use that Hailstone number and then ask the iterator for the next one. So there's this back and forth. You say there's a loop that's printing out the result of calling this method. It'll say, give me the first one. It gets the first one, prints it. And it says, give me the second one. Give me the third one. So the entire list is never generated in one place. It's just generated on demand. So let's take a break and we'll see how that works. Right. And then in the end,
Return gives you the number as you ask for it instead of consecutively reporting.
okay. So instead of saying, so up here it said console.writeLine start, console.writeLine 1. Down here it says yield return start, yield return 1. Otherwise, it's character for character the same. Well, the other one is a void method. This one returns an IEnumerable. Okay? So there's what's really happening, and there's how you can think about it. So let's start with how you can think about it. The only, okay, so when you're using, let's say somewhere else you're using this method, hailstone, in a loop. And in fact, let's go look at where it's used in a loop. Here's demo.cs. Here we are. We're using help. This is the loop we looked at. So we're consuming the IEnumerable right here. So basically, this loop runs, it asks hailstone for the first element in the sequence, it gets it back with that yield return, in effect gives the element back, which gets printed out by the loop. Then the loop tells the iterator, I need the next element. So it runs a little bit longer, gives the answer back. So the way to think about this is, this thing, when it's called, it runs until it hits a yield return. When it hits a yield return, it suspends. Whoever called it gets the first piece of the puzzle and does what it wants to with it. Then then this thing picks up again where it left off, keeps running until it hits another yield return, gives that back to the loop. The loop's done with it. We keep running until the method is done. So each yield return gives a number back to the loop. You had a question?
Can you describe the difference between yield return and return?
Okay. What happens when a method returns? It's over. You call a method, it returns, it's gone. You call this method, and it hits a yield return, it hangs around. It stays in memory. It remembers where it was, so that when it gets resumed, it can pick up where it left off. So each time when the loop says, next number please, it doesn't call this thing again. It just says, pick up where you left off. So the first number that was yielded was right there. When it's told to pick up where it left off, it starts right here, as if it had never stopped. And then it's up here and it yields something. The loop prints it out, says give me the next one. It picks up where it left off. So you can think of, I've got these two things running at the same time. Loop runs and says give me a number. This thing runs and says here's the number. Loop prints it, says give me a number. This one picks up where it left off and gets the next number. So you don't have to generate the whole sequence. Yeah?
So on that last iteration, it'll hit a yield return 1, and it'll pause right there.
Yeah,
There's nothing less in the method.
when it gets down to here, it yield return 1.
Repeat the question.
Okay, he's asking what happens when it hits yield return 1. So it will yield return 1, the loop will print it out, the loop will say give me the next one. But then the method will find the end for real. And then it's gone and the loop ends. Okay? That's the way to think about it, yeah.
Is there a lot of extra overhead having to come back to this method and tell it to keep resuming versus just running it all once?
Is there a lot of extra overhead? No, not really. And in fact, it's better for resources because it does not consume. Okay, here's the thing. Could you write a method that returns a list containing all prime numbers? No, because they're an infinite number. You cannot create an infinite list. You could write an iterator that produces all the prime numbers. It would do 2, 3, 5, 7. Each time it was asked for the next one, it would compute the next one and yield it. And it would just run until someone broke the loop. Okay? So it can do things that the other style could. You cannot create a list of infinite length. You can write a method that yields the next prime number every time you ask for it. Okay? I keep saying that's the way to think about it. In reality, what happens? You remember we were talking about up here in demo.cs, that this sort of loop here, this for each loop that's just writing, is shorthand for that loop right there. That where we're creating an IEnumerable object and then calling get enumerator on it, and then on that object we're repeatedly calling move next and current. Okay? When you create an iterator, the compiler sort of cuts the code up and it creates move next and current method, a move next method and a current property is what that's called. That does the right thing. So it's not really the two methods. It's not that the two methods are coexisting at the same time. The compiler is just being really clever in creating an object that contains the code you wrote, sort of chopped up and repackaged so that everything works right. It's not important to understand how all that works. So that's why I started with the way you should think about it. And just imagine the method running up till it hits the yield return, and then it can get it back, and then it can be asked for the next one. Now, how does the loop really ask for the next one? What's happening behind the scenes? Yep.
Calls a method again?
Well, no, it calls move next. So the iterator was chopped up, and an object was created that contains move next method that contains some of your code. And so the loop is repeatedly calling move next on that object. Move next current, move next current. And that's how it makes progress. But again, I don't want to turn this into a class on how to implement iterators. So I'm happy for you to think about it in the other terms, which is just, if I ask you to write a method like this, first of all, an iterator, how do you know something is an iterator? Well, you're going to see yield return in it. The return type has to be IEnumerable. And there can't be like a regular return in here. Right? Just yield return. The way I suggest students do it is start by writing a method that just prints out all the things in the sequence, like I did there. You can all do that. Then what's it take to turn this from something that prints out all the numbers in some sequence to one that generates everything in the sequence as an iterator? What do we have to change about this to turn it into an iterator instead of a printer? Yeah?
The return type.
Okay, you got to change the return type to IEnumerable.
And then the console outputs can be changed
Right. The right lines become yield returns. So it doesn't need to be any mystery. This is programming 101, writing a method that prints out a sequence of numbers. If you can write a method that prints out a sequence of numbers, you can mechanically turn it into an iterator. And we'll be making use of iterators a lot going forward. So I tell students often in this class, I get the feeling sometimes that you're sitting out there thinking, I don't get this, but maybe it will blow over. And I can go on. But you've taken enough programming classes to know that typically things don't blow over. If you don't understand something on the second day of class, it's going to cause problems down the road. So you can either understand it now or understand it later. So now is better than later. Yeah?
Is there any reason other than user ease to declare something as var rather than actually saying integer or string, something like that?
Yeah, it's just a convenience. So using var instead of the actual type to declare the variable, you can only do it if the compiler lets you, meaning it's configured out on itself. Right? It's just saves typing. It saves typing, but I think it's overused. It can make it harder to read your code. Yeah?
So an iterator is just a method that goes over some data structure, like one by one?
Well, an iterator is just something that yield returns a sequence of things. Doesn't have to be a data structure. There's no data structure here. There's no array or list or anything. It's just doing number computations. Yeah?
I think you already talked about this, but when you do return, does it just like make the method return wherever you return it keep going? Does it do you know what I mean?
Well, typically when you use an iterator, you've got a loop that's consuming it. So over here, you've got a loop that's calling the iterator. So the loop calls the iterator yields a number. That's the first value in the loop. Then the loop asks for the next element. So the iterator runs a little more until it hits a yield return, gives that back. Hmm? You can think of the iterator as pausing while the loop runs a little bit. And then the loop pauses while the iterator runs a little bit. That's the way to think about it. That's not what's really happening. That's a good way to think about it. Now, this feature, iterators, was first language that it was in was a language called Clue that was developed at MIT by Barbara Liskov in the early 1970s. So Barbara Liskov is a Turing Award winner, which is sort of the Nobel Prize for computer science. She was the first woman to get a PhD in computer science from Stanford, and became a distinguished professor at MIT. And she put that in her language, Clue, which, you know, it was an experimental language. But it took 30 years, I think, before it showed up in C#. She went around evangelizing, trying to get people to incorporate it in the language. And I think she finally went on sabbatical at Microsoft Labs, and that's when it showed up in C#. So her version really did behave like I said. There physically two things going on that took turns running. Okay, so that's iterators, and I have some slides that you can look at later. I'm going to show them to you here that sort of summarize what we just talked about. Yeah?
So that last yield return, wouldn't it make sense to just return 1 at the end and not have to go back into that?
You can't.
Is there like some reason for that? Is that just...
Yeah, iterators can't contain returns. Okay? So I took out the yield that says cannot return a value from the iterator. Now there is something called a yield break. If you want to just end the iterator at some point, the way you would break out of a loop, you just say yield break, and that ends the iterator, ends the loop that's using it. But you can't put a plain old return. Any other questions? Yeah.
So in the demo you had a last and reverse. How would those exactly work? Would you have to go through the entire sequence and work backwards?
Right. So when I had this up here in demo, this one, there's a first method you can apply to any IEnumerable. It doesn't have to be an iterator implementation. It can be a list, a set, or whatever. It just does what it has to do to find the first element. And what it would do is it would just sort of imagine running the loop once and then return the result. Max would have to consume the entire iterator and IEnumerable and then average them, or find the largest. In reverse, we'd have to get the whole sequence and then reverse it. Right, let's look at something different. We're going to look at this program here called grep. And this is the one that is most similar to the assignment you'll be doing. This is a project that is created, let's look at the properties here. And we'll look at application. And we see that it is a console application. So it's meant to run inside a console. It's not a GUI application. I just made it the startup project, and here we will open it up and see what it does. So you see it's in namespace grep, class grep, and this stuff all talks about how to run the program. And we'll worry about that later. So this is a project that's meant to run at the command line. So it has a main method. So that's how you create it, just like in Java, you start at the main method. Here you start at the main method. We'll talk about these parameters in a second. We'll talk about them now. So when you run a program from the console, you typically, what I'm talking about is we go here, we bring up a console window, command or PowerShell window. If I want to know what time it is, I say time. Well, that changes the time. I don't want to do that because this computer already is all wacky. All right, so I'm running commands. I want to say what's in this folder. I say dir. Those are command line parameters. If I want, that's a command line program. If I want to say what are all the zip files, I say dir star.zip. The star.zip is what you call a command line parameter. That star.zip is being given to the dir program, and it makes sense of it. Yeah.
Is this supposed to be blurred like that?
Is what?
Oh, nothing.
Goodness. Thank you. No wonder everyone's hand was up. Okay, well, we'll have to make this a theoretical command line program. Something, probably the resolution is messed up. Sorry about that. So anyway, let's look at what this program does. The first thing it does is it says, make sure we have exactly one parameter. It checks to see if that array that's coming in has a length that's not equal to 1. If it is, we write out an error message and exit. And what I was trying to illustrate right there is where command line arguments come from. So I think the best way to do that now, since I have a problem with my projection, is to come here and do it this way. Better save this. Clear it. So if I'm on the command line, what I was saying, and I just type the command dir and hit return, I've run a command line program. It lists all the files in the current folder. If I say dir star.txt, this string is sent to dir as a parameter, and it looks, the dir program looks at the parameter and figures out, oh, he wants all the files that end with .txt. And it just shows me that. So this is a command line parameter. And in general, when you run a command, like our grep program expects a single command line parameter, which is a word to search for. So I might say grep Joe, and then I hit enter. The grep program is invoked. Joe is passed as a parameter. It's passed as a parameter to it. You can have multiple command line parameters, and they're all passed to the program. I find it disorienting after all these years to have to actually explain to students what a command line program is, because that's all there was for a long time. And now it seems exotic to students, but it's really not. So when main starts up here, what's going to be in that array? Those command line parameters, the things that appeared after it ran, after its name on the command line. All right, so this makes sure there's exactly one parameter. So what it does next is it pulls out the first command line parameter, the only command line parameter, it calls it pattern. And then it starts reading from the console. So the user types something. Each time the user types a line, it reads the line. And if that line contains the pattern, it prints it out. So it's just reading a line from the user type and then echoing it if it contains the pattern. Okay? So that's how, this is a command line program. Yeah?
So I know pattern is a string, but what is args 0? Is that just the first?
Args is an array.
Okay,
See
so
up
it's the
here?
first element in that array.
Right. The parameter to main was an array of strings. So down here we're just grabbing the first parameter, the first member, the first element of that array.
Okay, so
Now, I can't run, because I can't show you, because I don't want to spend 10 minutes figuring out how to set the resolution correctly. But you can run command line projects from Visual Studio, which is nice. All I have to do, if I do Control F5, it runs it. And I can type at it. It's not doing the right thing there. But where does it get its command? What it does is it runs the command for me, and then it starts taking input from me. But where is it going to get the command line parameters if there's no command line to type at? Yeah.
Project settings?
Right, you have to do project settings to do that. So I have to stand on my head to run a command line, a simple command line program. I come here to Properties, and somewhere in here, I have to remember where. I didn't check out before class, which is bad. Debug. Okay. Right here, it asks me to supply correct command line arguments. So I'm going to make the command line, well, I'll just leave it what it was, the. So when I run the program, it's going to act as if I had typed grep the on the command line. And it'll start reading lines of text and printing out the ones that contain the. So let's run it again. Well, let's get out of there, we'll run it again, Control F5. There it is. So if I say hello, it doesn't echo anything. If I say hello there, it prints it out.
Yeah, see it.
This is a test. Oh, you can't see it, of course. Even in this mode, you can't see it. Anyway,
They kind of
Just
guess.
can't tell what they're saying.
that's interesting. Okay, so I typed hello, and then hello there. It echoed hello there. Then I said, this is a tweak. That's spelled wrong. It didn't echo anything. Okay? And it'll just keep doing that until the stream is closed. And that depends what operating system you're using. I think it's Control Z says there's no more input in the command. Okay? Now, here's the thing about command line programs. I talked about, last time I said we'd be using a pipe and filter architecture. So I'm going to go back to my this thing here. I wish it was easier to demo to you. So when you're on the command line, and we already said that you can run your program like this. You can say grep the, and then if I said hello, I typed hello, nothing would be printed out. If I said there, then it would echo there, and so on until I closed the input stream by typing Control Z. On a Mac, it's more like, at least in Linux, it's Control D, I think. It probably is in Windows, on the Mac as well. Okay? So that's running a command line program. So that's grep. Let's imagine another program. Why that one? Okay. So let's suppose there's a program called spell. And what spell does is it reads lines of text, and when it sees a misspelled word, it prints it out. So if you say spell and you say hello var, it would echo var. Right? But if you typed this, it would echo nothing. So now we have two command line programs we're writing. So what you can do at the command line is something like this. You can say grep, and you pipe to spell. So this here, this here is called a filter because it takes input and produces different output. And this vertical thing is called a pipe. So at the command line, you could type that. You could say grep pipe to spell. And how do you suppose that works? What happens when we run it like that? Back.
Would grep take spell as the command, whatever spell returns or outputs as the command line arguments?
It doesn't have to do with the command line arguments. Oh, in fact, that points out a good thing. We can't just run grep because it takes command line arguments. We would have to say something like grep the pipe spell. Okay? So we're saying run grep with command line parameter the, and then pipe its output to spell. I sort of just gave it away. So the way it works, the way pipe works is, or if this thing, the first command in the pipeline reads from standard input, just from the console. Its output is made available to this program on its standard input. So this thing gets as input the output of this program. And then the output of this program gets printed out to the console. And if we had other command line arguments, we could continue composing them like that. And so you get this pipeline. So if you write like say PowerShell scripts, for example, you often end up having programs you're invoking from a command line, from a script, and they get piped together. The output of one becomes the input of the other. So what's going to happen if we do this? Let me get rid of this stuff here. So suppose we have this situation, and the first thing I type is hello, and I hit enter. What output will appear, if any? None, because grep won't put anything out, and so spell's not going to see any misspelled words. Now, what if I say hello there? Again, grep will output there, but there is spelled right. But if I do something like this, hello vex, grep will output a line containing hello vex, because it's passing through lines that contain THE. That line is then sucked in by spell, and it will output vex, so the output would be THEX. And we could keep interacting this way until we hit Control-Z, Control-D, depending on what you're using. Okay, so this is an old-style pipe and filter architecture. But it gets even more interesting because you can do this. That's called redirection. What do you suppose happens there? Yeah?
Anything that would normally get output to the console is instead saved in that file.
Right. So now spell, instead of printing things out to the console, he gets a file is created, answer.txt is created, and the output goes into that. So when you're all done, you'll have a list of misspelled words that occurred on lines that contain THE. Now, it's a pain to type. Maybe you want to run this pipeline not on what you're typing, but on a file. Maybe you got a file that contains a bunch of lines, and you want to know all the words that occur, all the misspelled words that occur on lines that contain THE. Okay? You can also use redirection for that. I need a little more space here, so I'm going to do a bit of erasing. So you say this. So I could be showing you this live. So what that says is, you notice the direction of the arrow. This says, take input.txt and feed it into the beginning of this pipeline. And where would the output appear? Appear on the console. If you want to capture it, you would just on the same line, but I don't have room, I would say greater than answer.txt. So now when you run that, it just reads from a file, runs it through the pipe, and the output goes in answer.txt. And then you could look at it later. Yeah?
Does answer.txt, whenever you exit a new singing, does it get appended or like overwritten?
Okay, the way I've written it here, answer.txt has to be not exist. There are ways to override that. I think greater than, if I'm remembering it right, will append to an existing file. And you can also make it so that it just replaces the existing file. Yeah.
And of course, input.txt has to be in the current directory that you're working in.
Right. Input.txt has to be in the current directory. If it's one level up, you just say .. depends what you're doing, Unix. That would be, you do .. input.txt of DOS, you'd say .. if you're running, so that would be running on the other systems, and it would look one folder up to find the file. Now, what you'll be doing on your assignment is I'm going to have you write 3 filters, right? So 3 separate projects, each of which is a filter that takes command line parameters. And then I'm going to have you experiment with piping them together. So the idea is you can get them to work fine just inside Visual Studio, but then I want you to get the practice of taking these 3 things, going to the command line, and running things in the command line. And I'm going to now get out of this and show you how to do that, because it won't be obvious. So let's suppose that we have written this grep program and we'd like to run it from the command line. the question becomes, where is the program itself? Where is the final assembly? Okay? So what we have to do is we need to find where this solution lives. And if I go right-click on this thing and I say Open Containing Folder, this is the file. You'll see that I'm at josephzachary/source/cs4150vs/static methods, which is my solution, demo, which is my project, and then in here is demo.cs. So I'm in the project right now. You'll notice there's a bin folder for binary. I'll double-click on that. Now there's a debug folder and a release folder. What do you suppose they're for? Right. One contains the debug version of the program. One contains the release version. Let's go to debug. So if I double-click into debug, then in here you see, among other things, demo right here. It says it's an application. So if I were to go now to, if I were to open my command line, my shell, my command shell, and connect to the folder blah 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 /demo/bin/debug. So if I did cd all into it, then I could run demo just by typing demo. Or, right? So I just ran it by double-clicking it, but it disappears right away. So that's the executable. I can run it, and you can see it printed some something out and then disappeared. But if I could go, the idea is I could just go to the command line, cd to the right folder, type demo, return, and run, and I'd see the output of the folder. Okay? So, I wonder if there's an option to open a... You'll have to imagine what it looks like. But, CD stands for change directory. Directory is a folder. And you do a sequence. You need to get to the right spot so you can run the program. Okay? I find this assignment is not meant to be difficult. It's meant to be easy. It's meant to be an easy warm-up. But what I found in the past is students just seem to get all bent out of shape because it's not how they're used to using a computer. Command line parameters and pipes and filters. Okay? I want to quickly look at one more thing. First, I'll see if there are any questions that would help with the assignment. Yeah?
So we always want to use the debug one, not the release build?
Typically, I use, in that case, it wouldn't matter. Could use either one. But when you're developing, you use the debug so you can get full use of the debugger. And then the release version is faster but harder to debug. So the one you ship is the release version. Any other questions? Or I do something that takes 4 minutes. Okay, so we've looked at demo. We're going to look at delegates, which is kind of a scary thing to start with only 4 minutes left.